All right. So, next up, let's look at this. This is just part of the unit circle. I don't have the whole thing drawn here. So we've already talked about the degree measures at different places, and we've talked about the radian measure at different places. I'm also going to talk about the coordinates. So, if we're on an x-y axis here, then, and remember the unit circle has a radius of 1, so that means that the coordinates of this point right here are 1, 0, okay? And since here I'd be going 0 to the right, 1 up, this will be 0, 1. Okay? All right, so let's see if we can figure out what the coordinates of these other points are at 30 degrees, 45 degrees, and 60 degrees. These are very important places, special places on the unit circle. Okay, so the way we can handle this is by drawing a right triangle. So if I take this place where the 30 degrees is, I'm going to draw a line straight down to the x-axis. Okay, and then from the origin, I'm going to draw in the rest of a triangle right like that. Okay, and then, so I've got this triangle, and this angle right here, this angle would be in standard position, so hey, I know that's going to be a 30-degree angle, okay? Since I drew that straight down, or I attempted to, then that should be a right angle there. So wait a second, this is a 30, 60, 90 triangle then, right? This has to be 60 degrees up here. I'm not going to draw in the 60 because this is going to get a little crowded in a second. So I'm thinking, do I know any of the sides of this triangle? Well, I do, because I know what the radius of the circle is, right? So this is a radius of the circle, and since this is the unit circle, that means that this is 1, okay? So using that, I can get the rest of this. Remember, this is the hypotenuse. This would be the short leg. So my 30, 60, 90 relationship says I should divide. It's getting smaller. And that means I'm going to divide by 2. So this would be 1/2 then. Okay? And then going from the short leg to the long leg, I'm going to multiply by the square root of 3. Okay? Now that I've got the rest, the 2 legs of this triangle filled out, I can figure out what the coordinates here are, because I've gone right root 3 over 2 and up 1/2. Okay? All right. So that triangle was supposed to be represented right down here as well. Okay, so this is this triangle. So that's my 30 degrees, and I had 1, 1/2, and root 3 over 2. Okay? All right. So let's look at, let's do the same kind of thing with the 45 degrees, okay? So if I drew this in like so, well then I've got a 45, 45, 90, right? And it's going to get too crowded to put all the numbers in there. So I'm just going to do that down here at the bottom. This is supposed to be a 45, 45, 90. Okay? And again, I know the hypotenuse is going to be 1. Okay? And then going from the hypotenuse to the leg on a 45, 45, 90, I'm dividing. It's getting smaller. I'm going to divide by the square root of 2. Okay? So this side is going to be 1 over root 2. But wait a second. We're not in simple radical form. So that would be root 2 over 2. Okay? And in a 45, 45, 90, the 2 legs are congruent, so this is also root 2 over 2. Okay? So now, looking at the pink triangle, root 2 over 2 to the right, root 2 over 2 up. And there we go. Okay? Now this last triangle I'm going to draw, I'm going to do this one in green again. Maybe I'll do it with dashed lines to kind of differentiate it. And that's going to get right in the way of that 1 there. Okay, so that last triangle, that's going to be a 60-degree angle in the corner. Okay, the hypotenuse is still 1. wait a second, this is a 30, 60, 90 where the hypotenuse is 1. Well, this is the same triangle, right? It's just turned on its side. So the hypotenuse is 1. The short leg would be 1/2. The long leg is going to be √3/2. So this last one, I'd go right 1/2 up √3/2. Okay, so, oh, whoops, that's off screen there. Okay, so you'd really want to memorize the coordinates of those places. There's a little trick that you can use. If we look at the y coordinates here, this is √0/2, because that would be 0/2 is 0, right? This is √1/2, would simplify to 1/2. √2/2, √3/2, and this would be √4/2. And then you can do the same thing going in the opposite direction on the x's. √0/2 simplifies to that. This is √1/2, √2/2, √3/2, √4/2 simplifies to that. Okay, so that's just a little device you can use to memorize it if you like. Okay, on the next page, I'm going to fill out the rest of the unit circle. Okay, and I'm going to use what we've already done here. So I've got, this is 0 degrees, 0 radians, and it's a 0.10. Okay, so I'm going to fill out north, south, east, and west first. So this is 90 degrees, and it would be, well, let's do the degrees first. 90 degrees, this is 180, and 270. And this would be back to 360 here. Okay, so there's my degree measures of those places. The radians, that's when we're talking about the terms of pi. So all the way around is 2 pi, right? Then this was 1 pi. Halfway to 1 pi would be pi/2. So I'm going to use those little bars as fraction bars for the ones that are fractions. And then down here, this would be 3 pi/2. Okay. So now what I can do with the, these are my special places up here that I had from the last page. So let's put those in. So you can see this one is halfway to 90 degrees right there. So that's how I remember that. That's 45 degrees. And then this is going to be 30 degrees and 60 degrees. Okay. So the coordinates, we've got √3/2, 1/2, then √2/2, √2/2, and 1/2, √3/2. I'm just copying this from the last page, and this would be the 0.01. Okay. All right. So let's finish filling out just this quadrant first. So what I can do, if I look, I'm just going to highlight these spokes for a second. So 45 degrees is halfway to 90 degrees, right? So I can do the same thing with the radian measures. If I'm going halfway to pi/2, well, I'm just multiplying pi/2 by 1/2, and that would give me pi/4. Okay? And now what I can do, I know each of these like I guess they're eighth turns, but each of these 45 degree turns is going to represent a quarter pi. So I can kind of just count my way around. Now I'm only going to use, I'm going to skip the 30 and the 60, and so I'm only doing these ones with the 45 degree turns right now. But I can kind of just count my way around using that quarter turn is pi/4. So let's try this out. So 1 pi/4, 2 pi/4 would reduce to that, right? This then should be 3 pi/4, 4 pi/4. This is going to be 5 pi/4. 6 pi/4 does reduce to that. This would be 7 pi/4. Okay, so there's my radian measures for those ones. Okay, we can use the same kind of technique for doing the degrees. This is 45 degrees plus 45 is 90. If I add another 45, this is 135. Add 45 to that, 180. Add 45 to that, I'm going to get 225. Add 45 to that, I'm good there. Add 45 to that, I'm going to get 315. And another 45 puts me at 360. Okay? All right, so let's try that same kind of technique with the other spokes. So I'm gonna use pink for these two spokes, and I'm actually gonna recolor these ones as well because the north, south, east, and west spokes are gonna work. We're gonna need those both times. Okay, so each of these pink spokes is gonna be a 30-degree turn. And okay, and so let's think about this. This is going to be, if I'm looking at just the first quadrant now, and I'm thinking about that, I'm trying to ignore that green line in the middle, but I've got 3 equally sized slices of pie there, right? So that means this is a third of the way to pi over 2. So a third of the way to pi over 2, that's pi over 2 times 1/3. That would be pi over 6. Okay, so now I know that these pink spokes are pi over 6 radians. So we can count pi over 6s on the pink spokes, okay? 1 pi over 6, 2 pi over 6. Let's reduce as we go. 2 pi over 6 would be pi over 3. 3 pi over 6 does reduce to that. This is 4 pi over 6, 2 pi over 3. 5 pi over 6 doesn't reduce. 6 pi over 6, 7 pi over 6. 8 pi over 6, we can reduce that. 9 pi over 6, 10 pi over 6 would be 5 pi over 3, and 11 pi over 6 doesn't reduce. 12 pi over 6 is 2 pi, okay? And we can do the same thing with the degrees. 30 degrees is these are all 30-degree turns. 30, 60, 90. This is going to be 120 if we add another 30. Add another 30 to that, 150. 180, this will be 210. Skipping the green spokes, right? Adding 30 puts me at 240. 270, 300, 330, and back to 360. Okay? Now, I know this is a lot. I don't want to do right triangles to fill in all those coordinates. So what I'm going to do is, when I'm looking at this point, I'm just thinking, well, I went right root 3 over 2 up 1/2. So to get down here, I'm going right the same amount and down the same amount. So instead of going right root 3 over 2 up 1/2, I'm going right root 3 over 2 down 1/2. So that just means that y coordinate is going to be negative, right? Because I went right and down. So I'm doing the same thing here. I'm going right, but then I'm going to go down that amount. So this is going to be root 2 over 2, negative root 2 over 2. So looking at the ones right above it, it's just the y has changed because I'm going down instead of up, right? So this is 1/2 negative root 3 over 2. Okay? And I'm going 0 to the right, 1 down here. So there we go. Okay. You can do the same thing over here. Instead of going right and up, I'm going left and up. So I should go negative root 3 over 2 up 1/2. Okay. And then I'm looking at these, and I went left and up that much. And there we go. Okay, this would be negative 1, 0. Okay, and I'm going left and down. What I like to do with these ones, since I'm going left and down for all these, both coordinates are going to be negative, and I like to just take the polar opposite and change both signs. Instead of going right and up this much, I'm going left and down that much. Okay, and I'm taking the negatives of these, right? And then taking the negatives of both of those. Okay, and there we go. That's the unit circle with all of these special places that you need to know filled out. Okay. All right. So let's put this to use on the unit circle. If you think about sine, let's think about the sine of 30 degrees. Zoom out a little bit here. Sine of 30 degrees, well, that's going to be opposite over hypotenuse. If I had a triangle drawn in, I don't want to actually draw on this because it's got too much on it, but if I had a triangle drawn in like that, a 30, 60, 90 degrees, so that's my 30 degrees. Sine, I'm thinking opposite over hypotenuse. Well, the opposite here would be 1/2 because that's my y coordinate there, right? And then the hypotenuse is 1. So it's going to be 1/2 over 1, which is just 1/2. Okay? Now the hypotenuse for all of these is going to be 1. So it's always just going to be the opposite, which is the y-coordinate over 1. So that means on the unit circle, sine of theta of any angle is just going to be the y-coordinate because it's going to be that over 1. Okay? The same kind of way with the cosine, it is going to correspond to the adjacent over the hypotenuse. The adjacent here would be √3 over 2. Hypotenuse would be 1, so it's just the x-coordinate over 1. So it's just the x-coordinate, okay? And it works alphabetically. C comes before S in the alphabet, X comes before Y. So that's how you can remember which is which, okay? Tangent, we're going to have opposite over adjacent. So looking at this triangle, the opposite would be correspond to the y-coordinate, because it would be 1/2. And the adjacent would correspond to the x-coordinate. So this is going to be your y over your x, okay? And then these are just the reciprocals. So if sine is y, that means this is going to be 1 over y, right? If this is x, this is 1 over x. If this is y over x, I just flip it upside down. And there we go, okay? All right, so let's try this out with some examples then. So I'm going to use the unit circle to find the exact value. You know, I could put this in a calculator, but it's going to tell me a decimal. That's not an exact value. That's a decimal approximation. So actually, some of these you'd get lucky and would get the exact answer. But a lot of times you'll get decimal approximations. Okay. So sine of 60 on my unit circle, I'm just going to find 60 degrees and think, okay, well that's just the y-coordinate at 60 degrees. So it's √3 over 2. Okay. So this is my y-coordinate, right? That's kind of what I'm thinking. You don't have to write that down, but it's exactly √3 over 2. Your calculator would give you the decimal approximation of that, okay? And then cosine of 45 degrees, well, cosine, I'm just thinking about x, right? So I'm using these definitions that that we just went over. Cosine is going to be x. Okay. So I'm just looking at the x and y coordinates at these different places on the unit circle, okay? So cosine of 45 degrees, I'm just looking at the x-coordinate at 45 degrees, which is √2 over 2. Okay, so there's a lot of explanation to kind of get here, but once you're here, it makes these problems pretty quick. So tangent of 60 degrees. Okay, so this one's going to take a little bit of work because I have to do some division. I'm going to have my y over my x, so √3 over 2 over 1/2. Okay, and yeah, I got to simplify this, but hey, when you've got a complex fraction like that and both denominators are the same, you could write it as division and then multiplication, but what's going to happen is those will cancel. And then I'll just have √3 over 1, which is just √3. So there we go, okay? Now the sine of 150 degrees, I'm over here looking for the y, and that's going to be 1/2. Okay, so this one on your calculator, it would tell you 0.5, which is exactly 1/2. But these ones, you'll get decimal approximations, right? All right, 390. So 390 isn't on here. But wait a second, there's an angle that's coterminal with it. So 390 is represented by one of these positions. Just think about we're starting here, going around 360 degrees, and I still have another 30 degrees to go. And so I'd end up right here where the 30-degree symbol is. So it's going to have the same values for the trig functions. 390 and 30 will have the same deal because it's the same coordinates there. Okay, so I'm looking for the x-coordinate here, which is going to be √3 over 2. Okay, we can also do this with radian measures since we have radian measures filled out on here. So I'm looking for the x-coordinate at 7 pi over 3 radians. So I'm just kind of looking around. 7 pi over 3. Well, there's 2 through 7 pi over 3. Okay, here's 5 pi over 3, right? 6 pi over 3 is going to be 2 pi, right? So this one we're actually going around the circle more than once as well, okay? So what I'm doing here is I'm thinking, well, this is 5 pi over 3, 6 pi over 3. And then if I wanted to add, I'd have to add another third of a pi. So I can see another third of the pi is right there, right? So each third of a pi is like 2 slices. So you can count around like that, like 1, 2, 3, 4, 5, 6, 7. You could do it like that. So it's 2 pi, which is 6 pi over 3, and then 7 pi over 3. So x coordinate there is 1/2. Okay. And that's it for today. See you next time.